Hey, oh, there we go.
How's it going?
Good. How you doing?
Doing good. Feeling a little bit better about this section.
Yeah, this test was a little bit easier.
Yeah. I didn't quite finish the first one, but I was working on it. I got to question 8, I
Nice.
think, and start putting things into the table before it was time.
Yep.
So,
Cool. Well, that's good. Were you able to meet with the tutor at all?
not yet. I think I'm going to try to set something up tomorrow
Oh, okay.
or Thursday.
All right. Nice. I wonder if what we were missing on the last one.
Yeah,
Yeah.
me too.
But cool. Well, do you want to jump right into it?
Yeah, let's do it.
Sweet. So, question 3. In an ANOVA hypothesis test, we reject. Okay, the H of O, what does that mean? Is that
I think H of O is,
null hypothesis
I
or
think
no?
so.
Okay. So when the null
Null
hypothesis,
hypothesis.
it is okay, cool. When there is sufficient evidence to indicate at least one mean is different, from the others. Trying to find a good spot for this. And this one, I put true.
Same.
Cool.
All right, number 4. What requirements need to be checked when performing an ANOVA hypothesis test? Mark all that apply. I said data in each group are normally distributed and variances are equal in each group.
Yep, same here.
All right.
Hey, to check if each group is normally distributed, do the following. This one I put construct a Q and Q plot for each group.
All right, that's what I got.
Awesome. In the textbook, it also showed a histogram. Is that, or was I just? Did you see that too, or no?
I don't know if I did see that. Let me see.
Um, or is that a Q and Q plot?
Looks like
Let's
there
see.
is a histogram in part of it, but
Is that? Oh, maybe it's just to illustrate the data. Okay,
I think that's what
never
it was
mind.
for. Yeah.
Gotcha. Okay, yep. That's
So,
I put that one too.
so we assume the variance in each group is the same if the following happens. Isn't it the largest variance is less than 4 times the smallest variance?
Yep.
Okay. I marked a different one the first time and I just found the right answer before you
Oh, okay.
put it in.
Nice. Okay, question 7. An ANOVA hypothesis test is equivalent to conducting independent two-sample tests between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples? And I got 6 on this one.
That's what I got too.
Awesome.
So then I just got to number 8. So the smallest variance in the 6 groups. I pull up that chart. The smallest variance is at 27.208.
Um, I
Not
think.
sure what part of the chart you read.
Do you know how you got that one?
I just plugged all the information into the chart that I downloaded for ANOVA stuff,
Uh-huh.
and then it just puts it all into the tables on the right. There's some in the descriptive statistics, and it just has the variances for each variable. And the smallest one's
Oh,
27.208.
sorry. Where'd you get the descriptive?
Oh,
Where's that one at?
it's just one of the tables off the. Do you have the?
Okay.
Dude, I wonder if this is what we were missing last time. I downloaded the quantitative inference, um, and so in the reading, when it has the Excel instructions, says open the
Uh-huh.
file, quantitative inferential procedures, and do the following. And I found just the nice, big, huge ANOVA setup in Excel that you just plug everything into.
Oh, really?
Yeah. And so it makes
Where's that one at?
okay, so
Oh, so I've got the Excel sheet or the downloaded.
and so then you
Um,
open the quantitative inferential procedures, and then there's those little tabs on the bottom that you have to select, like which one you're
what?
doing. You want to select
Oh,
there's like
is
one
that
sample
another?
t-test, paired sample t-test. You want to click the ANOVA option.
Oh, wait. Where are you getting that one you're talking about?
The ANOVA.
Yeah.
Okay, so if you open the quantitative inferential procedures,
Is
it's got.
that in, where do we find that at?
So if you go to the online textbook, and
Okay.
3.3, it's the how to conduct an ANOVA test Excel instructions.
Okay.
It says open the file, quantitative inferential procedures. You click on that.
Hey,
Okay.
I have a favor to ask.
Okay.
And I'll totally pay you back for gas. Did you mind if I borrow your car?
For it.
Thanks.
Oh.
My battery's not starting and I didn't charge the battery pack.
Oh, yeah.
Pinch. Thank you so much.
Yeah. Where you headed?
So we're actually I'm gonna go get Haley and Caitlin and Austin and Trey. We're gonna get something.
Okay. Want to throw the sleeping bag in the back.
Okay, I will. Thank you so
Or
much.
just leave it
Jake.
there.
I really appreciate it.
Yeah.
And I'll pay you back for gas too.
Oh, you're good. Sorry about that. My roommate's borrowing my car.
All good. Okay. So
Yeah, so
quantitative descriptive statistics.
quantitative inferential procedures.
Okay.
And then, so you pull that up, there should be a bunch of tabs along the bottom that say one sample t-test, paired sample t-test, two sample t-test. You want to click the ANOVA option.
Okay. It's downloading. Wow. Look at that.
Yeah.
Dang
way
it.
better.
Okay.
It was like Christmas
So
when I
then
found
you,
that out today.
oh my, well, yeah. So you do the, oh my goodness, no way.
Yeah. Then you just plug it all in and it
And you just plug
calculates
in
it
your
for
different
you.
variables, and then it figures it out.
Yeah.
Jeez, where did it talk about this one, man? Dang it, good find,
Thanks. I was overjoyed when I found it.
man. So they have it makes sense. They would have it all in one file.
Yeah, it does.
Gosh, dang it. That should help.
Yeah.
Save
So
that one at the top of my file. Okay, so if that one you got, let me go back to it. What was it? What you got?
the smallest variance number I got was 27.208.
Okay,
So that's the
sweet.
answer for number 8, I think.
Okay. So then that chart gives you the maximum too, right?
Yeah. That's the next question.
Yep.
So the maximum is 53.158.
Okay. Gotcha.
So the test for equal variances is satisfied for these data. Is that where the one
Yep.
that has to be? Is it because it's not 4 times bigger?
Yeah. So largest variance is less than 4 times the smallest variance.
Okay.
So
So in 11, construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. Okay, so I need to. So now we're going to use the quantitative descriptive statistics file.
okay.
QQ plot tab, and you can paste in each of the 3 groups of data separately test for normality. Okay, so I want us to construct a QQ plot.
So now you're using not the quantitative inference, the other one.
Yeah, the quantitative descriptive, and we're going to use mine's. There we go.
Man.
Yeah, I wish I would have known about all of these a lot sooner.
Are you kidding me? It offers you just put the data in and it gives you everything.
Yeah.
Oh man, that's a bummer.
Wait, what
We were
data
all
do
trying.
we put?
What's that?
What data do we put in the QQ plots?
So this one. So I think we input all of them.
All of the variances.
For all of the samples. So we're just trying to see on the QQ plot if they're normally normal or non-normal.
Okay.
So normal is a straight line, right?
Yeah.
And the non-normal is like S-shaped.
Okay. Yeah.
So
So we got to place like all of the A through SOX data in there.
yeah. So you want to do the first three, and I'll do you do A, B, and C, and I'll do D, E, and F, or D,
Yeah.
E, and SOC. It even give you percentile. Oh wait, maybe I'm on the wrong. Did yours get scattered all over the place?
Yeah. So far, I'm going to go ahead and like put everything in.
You're doing what? Sorry.
I'm just going to go ahead and put everything in and see if that makes a difference.
Yeah.
Yeah, mine's scattered all over the place. Are we just supposed to? Do we put the samples in or the variances in?
I thought it was the samples. 'Cause it says 6 of the 6 samples.
Oh, and the a QQ plot for each of the 6 samples.
Uh-huh.
So they're not. So one of them, mine were all messed up. So does that mean they're not normal?
I'm trying to. So, did that line change for any of yours?
Oh, the line didn't.
Line stayed the same.
Yeah.
Yeah, I don't. I'd say false, maybe.
Yeah.
Yeah, I'd go with that.
Yeah, I think so.
Unless, yeah, I don't know. I don't. I would think they'd be more in a kind of a line.
Yeah.
But mine are all over the place. So
Mine too.
wait, unless how do you know how to sort the data?
Uh-uh.
That's what it says in the instructions. Copy and paste, and then there's got to be a way to do it. Oh, hang on. There has to be a way to. Let me do a quick search.
Okay.
Okay. Okay. So copy and paste the data, and then highlight it, and go up to sort, or up to data, and then sort. And once you do that, you can click from lowest to highest. And that made all of my data points normal.
Okay.
Because before it was using, I think, the other column, 1, 2, 3, 4, going up. So it's kind of posting them randomly. But if it's in order, it's normally distributed. So I think we go with true. Did that do that to yours?
Yeah,
Sweet.
did so. So I also did, while you were looking at that, I went ahead and did number 12,
Nice. What'd you get?
0.309.
Okay.
Just
Cool.
deleted the SOX data out of the ANOVA test.
Awesome.
So the test statistic for an ANOVA hypothesis test is an F statistic. If the P is a p-value, the area to the right or left of the F statistic. It's right skewed.
Yep. Cool. Okay. Question 14. Let's examine the calories first. Construct Q and Q plots of the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions to use ANOVA have been met.
All right, so you have to put all the hot dog stuff in the ANOVA first to compare the variances.
Okay. So put it into ANOVA first. Excuse me.
Okay. Are we doing, is it calories or sodium that we're looking at?
Calories.
Okay. Then I have to make them into QQ plots.
Okay. And we're looking to see if it's. We're just trying to see what we can find from that. Oh, we're just trying to see if it's normally distributed or not.
Determine if the assumptions to use ANOVA have been met. Yeah, so see if.
Okay.
And how do you put them in order again?
So if you highlight them, you go up to data on the top ribbon.
Uh-huh.
And then under data is sort.
Sort smallest to largest.
Yep.
Okay. Did you do the first one?
I did. Kind of did a wave, but it's mostly straight.
Yeah, mine looks pretty straight too.
I'll do the third one if you want to do the second.
Okay.
Kind of the same deal. What the second one look like?
Just a little bit. So the second one's a little more S-shaped.
Yeah.
It's got some outliers on it. Um, ooh.
So, would you say they are normally distributed or not?
Um, I mean, I think they would be. Let's see. So the variances definitely aren't equal. The second one
No.
is a lot different. The third variable is 508. Variable 1 is 512, but variable 2 is 636.
Uh-huh.
And so, actually, I think that'd be the second answer. Each group
Second
comes
one?
from a normally distributed population. We cannot assume that the variances are equal, I think.
You think the second one?
That's what I think.
So you think each group comes from a normally distributed?
Well,
They make kind of those F's.
yeah. So maybe it's not then.
So would it make that the last one?
Yeah, if that were the case.
Okay. Good with that one?
Yeah.
Okay.
Run an ANOVA test to determine if the mean number of calories is the same for all three types of hot dogs. You should find that the degrees of freedom are 2 and 51, that F equals 16.074, and P equals 0.000 with level significance equal to 0.05.
So this one's mostly talking about the mean number of calories. So variable 1 and 2 are the same, but 3 is not. Well, 1 and 2 are close, right?
For as far as mean goes,
Yeah.
yeah, that's what I've got.
So the last one?
Yeah.
Cool. Okay, now we get to examine sodium levels.
Sodium levels.
Okay.
Are you doing number 1?
I'll do number 3.
Okay.
See who finishes quicker.
I'm just gonna put them into the ANOVA thing at the same time, I think.
Okay. So poultry has some outliers, and it does like two little kind of angles.
Uh-huh. Beef has one outlier, and it varies from the line quite a bit, like pretty decent amount, honestly.
Uh-huh.
So
And then meat does the wave as well.
the meat does.
Yeah, with a couple outliers.
Okay, so they both have some outliers and they have a bit of a wave.
But for the most part, they're pretty steady.
Yeah.
It's not. I think if it's not normal, it goes straight and then it curves.
Okay.
Maybe we just have a little bit of variance.
Okay, so the
What'd you
first
get?
question is just asking, have the assumptions been met to use the ANOVA? So it's
Uh-huh.
10,492.871, 4 times bigger than 7,180.
I think that's been met, right? Because it's less than 4 times bigger.
Yeah. Does that mean it's been met or does that mean it hasn't been met? I can't remember.
I think it's mean it's been met
It means it's been met.
if it's smaller than 4 times.
If the largest variance is at least 4 times as big as the smallest variance, we will conclude that the population variances are not equal. If the largest variance is not 4 times as big, we will conclude that population variances are close enough that we can assume the variances are all equal. Okay. So it's not 4 times bigger. So would you say it'd be the first one?
I think so.
Yeah, because the rest of them have not been met.
Yeah. I hate those because it throws you off.
Yeah. So number 17, the p-value for the test, I got 0.179.
Okay. Sounds good.
And what conclusion can you draw about the mean sodium levels of the 3 types of hot dogs? Use a level of significance equals 0.05.
What were the means of the sodium levels?
The means, beef was 401, meat was 418, poultry was 459.
So how do you use that level of significance?
That's what I was just trying to figure out. They all have different mean sodium levels.
Uh-huh.
So it'd be the third one.
different are each of the means?
Well, I guess there's 17 in between 1 and 2, and 58 between 1 and 3. And those are the biggest differences. Whatever 59 minus 18 is.
Yeah.
But with their standard deviations, they all could be the same.
I kind of think we don't have sufficient evidence.
Yeah.
We're kind of in between knowing it.
Yeah. So would that be the second one?
Yeah.
Okay.
Sweet.
I'll submit it.
Okay.
See what the damage is.
Yeah.
I feel pretty good about it right now.
Yeah, this is pretty good. Okay, if my phone dies, I apologize. I got 5%. So
Okay.
we'll
So
see
we
if it lasts.
5%. The one we missed was question 14.
14.
Yeah.
Okay. We picked the last one, right?
Yeah, we did.
Shoot.
Number 14 is about the calories.
Since on that last one, did we get that? What about the same question for the sodium? Did we get that one right?
Yeah.
Because those kind of made that S shape too. Do you think we should click that the assumptions have been made, have been met?
I'm guessing so. 14.
14. Because their means were similar, right? Or I mean, not their means, their what's it called? Their variance.
Yeah.
Maybe we go with that one, the first one.
I think so. I think it'd be worth
Worth my shot.
Yeah.
What was the next one?
Huh?
What was the next one we got wrong?
Oh, that was 14 was the only one we got wrong.
Well, that was the only one.
Yeah.
Nice. Let me submit it. I hate how there's like 3 different submits.
I know.
So I just I know what I'm doing.
Yeah.
Okay, that's the first one.
It was the first one.
Yeah.
Okay. I'm gonna do it again so I can get 100
There you go.
because I just as well, right?
Yep. Well, thanks for meeting.
Yeah. Thank you.
Appreciate it. Look at that. Look, getting us hundreds.
Huh?
Getting us the hundreds that we need for the past 2 weeks.
Yeah. Finally
Finally got
found
it.
them. We were
Yeah.
missing something. The whole.
Because we were trying to figure out that Excel sheet on our own.
Yeah. Trying to solve it by hand.
Yeah. Oh man.
No wonder it wasn't making sense.
I know that makes it 100 times easier.
Yeah, it does. Hardest part is just going to the work to copy and paste everything.
Yeah, no, it gives you the answer. Even for the one sample t-test, it gives you it.
Yeah.
Oh man.
It makes a big
Cool.
difference.
Well, that's a bummer. Now you're stranded at home.
Huh?
Now you're stranded at home.
Yeah.
Okay.
Yeah, if you gotta go, I'll go ahead and upload the thing, like the link on there and everything.
Awesome. That'll work. Thank you.
Yeah, thank you.
And we'll see ya.
See ya.
Bye.